We're going to take a look at section 8.4, and now we're solving radical equations. So when we're looking at this, our goal is to get the radical by itself if possible. If we have radicals on both sides, that's fine, but if we only have one radical, we definitely want to isolate it. And another thing about these equations are, and I know I'm terrible about this, but you really need to check your answers because a lot of times they just don't work when you go back to the original problem. So we have an example, a worked example. Square root of x minus 2 equals 5. So we want to get the radical by itself by adding 2 to both sides. And then you have square root of x is equal to 7. So we talked about in 8.1, when you square a radical, it gets rid of it. When you take the square root of something squared, then it gets rid of the exponent. So we're using the fact that when you square a square root, you just get what's the inside the radicand. So we get x here, 7 squared is 49. And then they went back and checked it. So here's our original equation. We plugged in 49 for x, so we get square root of 49 minus 2, or 7 minus 2 is equal to 5. And this one does work. So 49 is a solution. So our first example, square root of y plus 3 is equal to 7. I'm going to first subtract 3. And I get square root of y is equal to 4. And then I'm going to square both sides. And I get y is equal to 16. Back to the original. Square root of 16 is 4. 4 plus 3 is equal to 7. So that does work. Here, I'm going to subtract 3 from both sides. And I get square root of x plus 1 equals negative 3. I square both sides. I get x plus 1 is equal to 9. Subtract 1. And we get x is equal to 8. So when I go back to the original and plug in 8, I get 8 plus 1 is 9. Square root of 9 is 3. Let me write this out. So 3 plus 3 equals 0, or 6 is equal to 0. Well, 6 does not equal 0, so therefore there's no solution to this. It doesn't work. Number 3, first I'm going to add 12 to both sides. Oh, by the way, this one, I knew it wasn't going to work because when you take the square root, remember this always has to be positive. And then I'm adding 3 to it. So I have a positive number adding 3. There's no way it could equal 0. But if you don't notice that, that's fine, but you have to go back and check. Alright, so first I added 12. I have the square root of 2y minus 1 is equal to 5. Then I'm going to square both sides. So 2y minus 1 is 25. I add 1. 2y is 26. Divide by 2. And I get a solution of y is equal to 13. So again, I need to check. 2 times 13 is 26 minus 1 is 25. So square root of 25 is going to give me 5. 5 minus 12 equals a negative 7, so that's okay. So this answer works. So what do you think about 4? Do you think it's going to work? I'm subtracting 8, and I get square root of x is equal to a negative 8. I know that's not possible, right? Because I'm taking a positive number. It has to be positive. When I take the square root, I'm going to get a positive. So there's no way that this is going to work. But again, if you don't notice it, and you square both sides, you get x is equal to 64. And then when you go to check it, square root of 64 is 8 plus 8 does not equal 0. So there's no solution. So like I said, it happens a lot that you wind up with a no solution. Alright, number 5, there's radicals on both sides, so I can't just get a radical by itself. So I can go straight and just square both sides. And I get 2n plus 1 equals 5n minus 2. And solve that for n. So I'm going to subtract 2n from both sides. And then I'm going to add 2 to both sides. And I get 3 is equal to 3n, divide by 3, and we get n is equal to 1. So check it. 2 times 1 is 2, 2 plus 1 is 3, so the square root of 3 over here. Plug in 1 there, 5 minus 2 is 3, so square root of 3 equals square root of 3. So this one does work. Alright, number 6. Again, I want to isolate the radical because there's only one. So this is a little bit messier because when I go to square both sides, we have to make sure we FOIL that out. So I get 1 minus x equals x squared minus x minus x. So I get a middle term of negative 2x plus 1. Now I have a quadratic, so I need to have this set equal to 0 so I can factor it. So I'm going to subtract 1 and add x to both sides. So I get 0 equals x squared minus x. So that factors to x times x minus 1 because I can pull out a greatest common factor. So my solutions are x is equal to 0. And this one would give me a solution of x is equal to 1. So let's see if they work. If I plug in 0 here, I get 1 plus the square root of 1. So 1 plus 1 is 2 is equal to 0. Does not work. If I plug in 1, I get 1 plus 1 minus 1 is 0. So 1 plus 0 is equal to 1. So that term does work. Alright, number 7. I have radicals on both sides, so I'm just going to square them. Again, this is a little bit tricky because that 2 is not in the radical, so I have to make sure I square that. So 2 squared is going to give me a 4. And then when you square the square root of x plus 6, it just gives me x plus 6. And then on the other side, when you square it, we have the x squared plus 19. So I'm going to distribute this. And again, I have a square root. I have a square term, so I have to set it equal to 0. So I'm going to subtract 4x and subtract 24 from both sides. And now I can factor that. So x minus 5, x plus 1. So one solution is going to give me a 5 because when you set that equal to 0. And then when you set the other one equal to 0, the x plus 1, you get a solution of negative 1. So I got to check. When I plug in 5 here, I get 2 times the square root of 11. When I plug in 5 here, I get 25 plus 19 inside, which is 44. Well, if you break down 44, it's 4 times 11. So I get 2 square roots of 11. So even though it didn't look like it matched, after I simplified, it did match. So the 5 is fine. If I plug in negative 1, I get 2 times the square root. Negative 1 plus 6 is 5. So 2 square roots of 5 on the left side. When I plug in negative 1 here, I get 1, because when you square it, plus 19 is 20. So I have square root of 20 on the other side. So the question is, do they match? Well, they do, because 20 is 4 and 5. So when you break it down, we get 2 times the square root of 5. So both of these answers work. And then the last one on this page, we first have to move that 5 over. And then square both sides. And again, this time we have to FOIL, just like the last, the one up here on number 6. So that gives me 3x plus 7 equals 9x squared minus 30x plus 25. I got to get that equal to 0. So I get 9x squared minus 33x plus 18. So I know that I can factor it a little bit because 3 goes into all of them. So 3x squared minus 11x plus 6. 9, 10, 11. Okay, so that would factor. And I'm so out of space down here at the end of my paper. To 3x and x, and then we need 9 and 2. So 3x minus 2 times x minus 3. I can't make 3 equal 0, so that one's irrelevant. I can set 3x minus 2 equal to 0. So I get 2/3, and then the other one, when you set that equal to 0, we get a positive 3. So 2/3 and 3. When I plug in 2/3 here, I get 3 times 2/3, which is 2 plus 7 is 9. Square root of 9 is 3. 3 plus 5 is 8. When I plug in 2/3 here, I get 2. That doesn't work. When I plug in 3, I get 3 times 3 is 9, plus 7 is 16. Square root of 16 is 4. 4 plus 5 is 9. And when I plug in 3 over here, I get 9. So 2/3 did not work, but 3 does.